Good morning, this is Bruce. Lovely Wednesday morning in Western Australia. Welcome to my shop once again. Today I'm going to show you a short movie on how I make my sockets, special sockets for the special nuts. These nuts I manufacture for impellers on submersible pumps. Now, in order to lock them up, you need a special socket. So what I do is I take this, take a socket like this. It's an impact socket. I don't use the chrome ones. I use these because they're a little bit softer. They're tough and they're a little bit softer. And then I machine them so that that socket will fit inside. But of course we want to fit it in like that. So what I do, unfortunately, this is a 1-inch drive, which is the right size for what I want, but and with a very good wall thickness. However, it's much too heavy and I only need a 1/2-inch drive. So what I do is I take, this is 1 1/4 inch, I take this socket and I machine it so that I machine 2 sides down around and leave 2 flats, 2 of the original flats. I leave them and I machine it so that the socket will slip in. As you see there, that socket just slips in there. Now, because of the I've taken so much material away from the edges here, what I then do is I then make a sleeve. I machine up a sleeve. I just did that now, and I press it on and silver solder it or TIG weld it. You can see there. I'll just demonstrate that now. I'll come down on the bench. Maybe come in a bit. Okay, so I'll just make that just more or less a slip fit. Doesn't need much persuasion because it's quite thin. There we go. So we've added extra meat to the outside here in order for this to work, and then I'll just sweat in a silver solder because it's got no load on it. And the only thing is an expansion, and to save that thing. So there you have it. It's a nice neat fit, and the boys in the shop can do whatever they need to do to take these off, put them on again. So now we'll swing back over and I'll just give a small demonstration on the machining facet of it. So what I have here, I have a rotary table set up with the chuck on top of it. I've set the the parallel sides, which I don't want to machine, are in line with the x-axis, and I know how much I've got to machine out. It's an 8mm cutter. I go down in increments of 3mm depth. They're quite tough because of chrome vanadium, and then I machine in till I get the depth I want. So off centre I need to get to 16.2 millimetres, and then I actuate around in both directions until I get to the angle I want on both sides, and work my way down. So I'll just demonstrate a quick one here on doing this machining and producing the 2 half moons that I need to in order to make that. So the other thing I've got, the other feature I've got is this little magnetic based lamp, and I use that to be able to see the 0 point or the whatever angle I need on here. So I'm running, the angles I'm working on is 310 to 50 degrees, 300. And so what I do, because when I come to the edge, the same edge of the line of the flat that I'm leaving, I'm in deeper than that edge, so that the milling face is deeper in. I need to come back out of there in order to travel across to the other side. So what I'm doing, I'm using the same angle for both sides, and I just articulate from one side to another, so along the x-axis. So what I do is I bring it back to 0, move across to the other side to the depth I want, or the diameter, and do that one. So do that, then progressively work my way down. I'll just come in there maybe a bit closer, and you can see this operation. Hopefully I won't interfere with too much with my hand movement. So we're running at about 1200 RPM, 8mm diameter cutter, just a regular 4-flute cutter. We're on 0 now. We're down on 3mm depth. I've locked up the quill, locked the X drive, and off we go. Now we've got to go, we're only on 11mm. I'm looking up here, you can't see that. I'm going to go into about 14.5 for the beginning, and then just rotate around till I get to the angle that I want to. So in this case I want to get to 50 degrees in this direction. Of course if somebody had a CNC it would go a lot quicker, but the one-offs, by the time they program it, I don't know whether they can make it any faster than I can make it. Now I go the other way. I'm going to come round to the desired angle that I want, which is 310. 10, come back, 0, go across to the other side. Just this first cut I do it in the increments until I get to the outside diameter, and then I plunge down to do the other. And there we go now, I'm swinging around on this side. Up to 310 degrees. And back to the other side. I'm going to take more depth now. I'm going to come around 40. Going in another millimetre. Spinning it around again. It may seem laborious, but it's just for my first option. We're at 310. It doesn't take long. Quite a bit of setup time involved, of course, and running around getting the pieces. 50, back to 0. And on that second depth, so we go across to the other side, plunge that through. 15.5. Same thing. We're going to roll around to 310 degrees. Back the other way. making these for about 6 years now, I think. Hello, just a second, I'm on the video at the moment, but you could come by and have a look, there's no problem at all. I'm going to plunge into full depth now, full diameter. Morning. Back around there to 310 degrees. Swing it back to 0. Across to the other side. Now the full diameter. Plunge down another 3 millimeters. Now we're on full diameter and our second cut. The other side. Okay, any more of that and it'll be boring. So there you have it. That's how we produce them. And as I said in my previous video, we need help to get to the States again this year for my mentoring and joining them at the bash. So one thing is the sale of the caps, and the other one, of course, of my getter out gauges. So I've already said that before, but there's all the details. If you can send me those details, and then we'll arrange the payment and sending off to you. Thanks very much for watching.